So, guys, like I said, the last time we stopped our discussion at the examples of severity and probability uh, descriptions. Let me show you some of the previous slides. As you can see, we've discussed the consequence description of the consequences, as well as examples of the descriptions. You can see here in terms of illness levels and financial loss levels. You can see here also that we have the consequences with various kinds of impact, like injury. Also, you can see we have uh, you see we have injury. You see we have safety, damage to property, environmental impact, as well as public impact. And we could have probably possibly other kinds of impact like business impacts and all that. We also briefly mentioned consequence analysis and provided some of the resources that you may want to consult for better understanding or information, more information on consequence analysis. Also, we discussed about likelihood and the descriptions of likelihood. Uh, we also talked about choosing between likelihood of occurrence as well as likelihood of exposure. I'll mention particularly for fatal or serious incidents, which are called FSIs, right? Basically, you take the higher value between the likelihood of occurrence or frequency of occurrence and frequency of exposure. And in this table, you can see the descriptions of frequency of exposure as well as descriptions for frequency of likelihood. All right. And if you have very serious injuries or fatal or serious incidents, you need to choose the higher value of these two. Okay. Now today let's look at some other examples of severity, that's consequences, severity of the consequences, as well as likelihood. You can see here we have a 5 by 5, 1 to 5 description over here, as well as 1 to 5 over here as well. And for catastrophic, here we have one or more fatalities, total loss of the system, chemical release with lasting environmental or public health impact. Is classified as 5. Okay. Here is saying disabling injury or illness, major property damage or business downtime, chemical release with temporary environmental impact. So it's only considering some impacts which has to do with impacts on people in terms of fatalities or injuries, damage to property or loss of a system, business impacts on the business like downtime, as well as release of chemicals with environmental impacts, okay, or public health impacts. So these are the only thing it's considering. It did not estimate any of that in terms of the financial cost, okay, in this case, okay. Nothing is mentioned here about the financial cost of the risks. So similarly, you can see, let's look at the last one. Here it says inconsequential with respect to injuries or illnesses, which means it doesn't lead to any of that. A system loss or downtime is also inconsequential to system loss or downtime, which means it doesn't affect that or environmental chemical release. Now let's look at the likelihood or probability. Here it simply says likely to occur repeatedly, probably will occur several times, could occur but hardly ever, improbable may assume incident or exposure will not occur. So you can see here it's not giving really detailed descriptions of what this means. This is more like a very subjective way of describing the probability. Okay, saying likely to occur repeatedly. Then how do you determine that? Okay, so you can see from some of the previous descriptions that we have more better descriptions of the probability. So all these types of things are what you can fix, okay, in choosing your or in designing a risk assessment system. Okay, you can do some research and see some examples of how the probabilities have been described. Okay, and then you can adjust this and come up with something that is acceptable by your top management or decision or by the decision makers. Now, this is also an example which is also very useful. Okay, that is kind of inverted in this slide. Mhm. Let me see if I can rotate it. All right. Can't find anything like that. All right. So basically here in this slides we have let me try to rotate this. Okay. All right. I hope this is clear. So you can see that in this slide we have basically severity or illness consequence. Okay, here and over here we have the likelihood. This is called the risk matrix anyway. We're going to discuss about the risk matrix in some other lecture, but it's not really a very big deal. All right. So here we can see we have a 4x5 matrix. Okay, or 5x4 matrix as you like. So we have this from 20 is the highest, and of course 1 is the lowest. So the basic description of the risk. For this, we already discussed about this previously regarding the frequency of occurrence as well as frequency of exposure. So you can see here, rather than simply giving the very likely to occur or improbable to occur, it actually gives more, has some more information on what could lead to that. For example, in terms of the frequency of occurrence, here it says task is performed several times a day. So it gives you a timeline. Duration may approach 1 to 4 hours a day. So this is actually kind of it gives some level of objectivity in determining what is probable or what is occasional, all right, and what is remote. Here also you can see here, these are some examples of actions that may be taken, right, depending on what kind of risk you come up with from this risk matrix. Okay, so you can see examples of actions that may be taken when you have anything between 1 to 3, and that is low, greater than 3 and less than 7 is medium. And what can you do in this case? Okay, so you give some suggestions on controls that you may want to put in place. Now, this is another example here. You could see here also similarly, we have a 5x4 matrix. In terms of the likelihood of occurrence, you can see here it says almost certain to occur, but here gives some more objective definition where it says has occurred more than once within the last 12 months. Okay, so you can actually determine what you mean by almost certain to occur. Very likely to occur once within the last 12 months. Okay, likely to occur if conditions exist within the last 24 months, while this is 36 months. And as this has not occurred within the last 5 years. So this gives you an example of frequency based on historical occurrence. Okay, based on the rate of occurrence from historical data, you can actually define the frequency as shown in this table. As for the other one, where you talk about the severity of consequences, it talks about the impact on people in terms of fatalities, serious hospitalizations, incidents resulting in more than 250,000 losses. Okay, so it gives you a financial impact here. Disabling injury or illness, permanent impairment, that's on people, resulting in more than 50,000 losses. Here is not talking about the system loss or loss of business downtime or environmental effects or impacts on public health. It simply mentions financial loss, whereas it's possible that all that may be factored or the cost of all that may be estimated and just lumped as a financial sum. Okay, and you just describe the entire loss in financial values. Okay, why you consider the fatalities and injuries separately. Okay, so this all depends on what is acceptable and what is uh, reasonable and understandable in your organization. Okay, So we have medical treatment or restricted work, recordable incidents resulting in more than $1,000 in losses, okay? And you can see here. So you can see also this is more like the risk matrix that tells you which range you consider as very high and which range you consider as very low. And like I said, we're going to discuss this soon. Now let's talk about controls, okay? Because we talked about assessing the controls. I think here, well, firstly, I think it would have been better if we talked about the hierarchy of controls first before talking about this, but that's okay. The hierarchy of controls is simply what you can see here in this table, okay? Elimination. These are various strategies, as we probably discussed in the first lecture, that can be used to reduce, eliminate, or basically just to control the risk, okay? Now, we have what we call the prevention effectiveness or prevention factor. I told you here last time when we discussed about various factors. You can also have what you call the prevention effectiveness. All right, because even if you have an existing control or recommended control, then it has its level of effectiveness on reducing the risk. So the adequacy and effectiveness of existing control measures greatly affect the level of risk and must be assessed. So this assessment of controls should include determining the type of controls for each specific risk and a judgment of their effectiveness based on the hierarchy of controls. The hierarchy of controls starts from what is high, like elimination, down to something as low as PPE. Okay, so usually you start from the higher levels of controls and then you move down to lower levels of controls. So you could see here that the elimination is almost close to zero, that's 0.1. So let's say, for example, you calculated the risk as severity being 3 and likelihood being 4. That gives you a 12. Okay, so let's say your risk score is equal to 12. Then you want to multiply by your prevention factor or prevention effectiveness of 0.1 for elimination. As if you use an elimination strategy or control, this gives you what? 1.2. Okay, this gives you 1.2. So you see, you bring down the risk score from as high as 12 down to 1.2. On the risk matrix, while 12 could be great. Okay, 12 or greater is very high, so you're gonna call that very high. When you bring it down to 1.2, then that is low. Okay, that makes the risk acceptable, like that. Now, if you say you have 12 and then you use a different kind of strategy like PPE, then that's going to be 12 times 0.9. Okay, that will be 12 times 0.9. And that's probably still going to be something around 11 or thereabouts. All right. Or if you don't use any controls at all, then it still remains 12. Okay. So basically, this is how you use the prevention effectiveness or prevention factor as shown in this table. And that's how you can assess the effectiveness of the controls that are either existing or that you have recommended. So this is another way also
Doctor,
to, yes?
from where these numbers for elimination and
Yeah,
substitution
yeah,
zero
these are,
point 0.1, 0.4,
yeah,
from where calculated?
yeah, these are suggested numbers, okay? These are suggested numbers by some other experts, okay?
Oh,
So, if you are of the opinion that the effectiveness of these various controls are not as high as this, then you can adjust this, or you can suggest some values and come to an agreement with your other team members or your colleagues, depending on your own engineering judgment and depending on your experience. You may decide that elimination is not as could not be as low as 0.1, but probably elimination might be 0. But rather than 0, you want to still keep you want to be on the safe side by still assuming that the risk is present. Okay, so for elimination, you don't want to use 0. You could say, for example, avoidance of the risk, which is a higher level, okay, or some other skills. Avoidance, you could say 0, which is okay, because you're avoiding the risk totally. But for eliminating the risk, it's possible that the control may fail, all right? So you want to use 0.1. So it's up to the risk analyst, and based on his experience and his engineering judgment, and he may also come to agreement with some of his colleagues on how to define some of the effectiveness of various controls. Okay, so these are just suggested values by some experts, all right, and then this can also be modified by other experts, which they feel that these values may be adjusted. Okay, now here also you have this. There's another way you can do that, as shown in this diagram. I'm going to explain this to you now as well. All right. All right. So if you look at the first one, we have what you call avoidance or elimination. Okay. And what are examples of that? You eliminate human interaction with the system. Okay. By using automated systems and things like that. You replace or eliminate a reaction step, eliminate pinch point or increase clearance. This is just various strategies depending on what kind of system you're working on. Now, reduction factor, okay, semi-quantitative. When you're using semi-quantitative risk assessment, 100%. So you can hear say this is saying it removes it completely. You know, 100% impact. It means if you use avoidance or elimination, you're going to get zero risk. Just like I said earlier, unlike saying using 0.1 multiplied by the risk score. Here it's saying you use zero, okay, 100%. But if you're using example of that could be, for example, elimination of human interaction may also eliminate exposure, while eliminating or avoiding reduce the assessment based on the new task. Okay. However, if you're using something like substitution, examples of which include automated materials handling, like using robots, using conveyors to greatly reduce human interaction, replace with less toxic compound is another example of substitution. Greatly reduce speed, noise, weight, energy. Okay, this is also another form of substitution. In that case, you may be able to reduce the risk by 90%. Here it says substitution with little or no hazard. Substitution with something that still has some hazards. Okay, so we could have more effective substitution or a less effective substitution. So in this case, you multiply by 0.1, which is 90%. So you multiply by 0.1. In this case, it's 80%. You multiply by 0.2. Okay, the risk score. And here, example, it says replace oil with water. That's for the first one. Okay, replace lifting 75 pounds with 5 pounds. So you can see it is greatly reduced. In the other case, say replace flammables with non-combustibles. Replace 75 pounds with 20 pounds. So you can see non-combustibles might still have other kinds of hazards, unlike just using water, which is probably is not a hazardous material. And 75 pounds to 20 pounds is not like 75 pounds to 5 pounds. So you can see that you can adjust the prevention effectiveness based on the kind of controls that you are suggesting, even if they are both substitution. Or you may use your intuition or your engineering judgment to determine the control effectiveness, all right, and adjust it accordingly. Similarly, if you look at engineering controls, here you can use barriers, interlocks, presence of sensing devices, machine guards, pressure relief valves, no-skid floor coatings, two-hand controls, emergency stops are not in engineering control. All right, so basically you could see here that likelihood, 70% isolation or guards with interlocks. 60% if you have multiple engineering controls. Okay, so 70% if you have isolation. Isolation means you're completely isolating the person. There's like a barrier of protection or a guard between the person and the hazardous area, okay, or the hazardous equipment. You have 60% if you have multiple engineering controls. You're using more than one controls. okay, which is not isolation, less than isolation. And 50% if you're using just one engineering control. All right. So you can see here for this, for the first one, guards that have interlocks, okay, 2 hand control plus light curtains, that is 2. And this one, 2 hand controls or just light curtains or just barriers. Okay. So if you have just one control, you use 50%. So you multiply by 0.5 in this case. Okay. In this case, multiply by 0.4, and in this case, multiply by 0.3. Okay, this depends on the level of effectiveness. Also, you can see here, active, reduce 1 level. Now, this is here you say, this is the likelihood. Here, you reduce the severity here. Now, what this means, when I say reduce severity by 1 level, it means that if you're using qualitative risk assessment, where your severity is, let's say high, okay? So reduce by 2 to 3 levels means you can bring your severity down. Now, this is just the severity, not the likelihood. You can bring your severity down to, if the next level is high, medium, low, and then you have very low, while this is very high. So if you're starting at, let's say, high, you can bring it down 2 or 3 levels, which means you can bring it down to medium, to low, or very low. Okay, you can come from here or here. That means 2 or 3 levels. Okay, if you're using qualitative risk assessment where you don't have numbers, you simply just have very high, high, medium, low, very low. So you bring down the severity in this case. All right. Now, in this case, you can bring down the likelihood for engineering controls. Okay, because engineering controls does not remove the severity, it only affects the likelihood. So in that case, you can reduce the likelihood 2 levels if you're using passive controls. Okay, or if you're using active controls, you can reduce it by 1 level. Now, 2 levels means, let's say, from very high, 1, 2, down to medium. But if you're using active controls, from very high to high. So what is the example of passive control? You can see here these examples. As for active controls, here it says lockout and tagout, where a physical device like a lock requires human intervention to initiate. All right. So 40% engineering controls that require admin intervention to initiate. Okay. Unlike something that is passive, that is already designed into the system. So you have 40%, so you just multiply here by 0.6. Okay, so you can understand this is how you go through the, okay, this is how you go through the, what do you call it, controls, and how do you assess the effectiveness of the controls. If you look here as well, these administrative controls and these PPEs, example of administrative controls are listed here: safe work practices, safe inspections, training, lights, beacons, and strobes, worker rotation, signs and labels. Whereas for PPEs, you have earplugs, gloves, respirators, safety glasses, face shields. And what are the effectiveness of these? For qualitative risk assessment, you bring what? You bring down the likelihood by what? By 1 level. So you come down from the likelihood, say you have high, you bring it down to medium. Okay, this means 1 level. For PPEs, you cannot change the likelihood. Okay, no change unless accompanied by your administrative control. Okay, but you can, if you can apply 10%, 10% effectiveness, prevention effectiveness for PPEs. If you have multiple PPEs, more than 1 PPEs, so simply multiplied by what? Multiplied by 0.9. Okay, for multiple PPEs, and 0.95 for one just single PPE. Okay, as prevention effectiveness. For this, you can see 0.7 and this 0.8. Okay, and admin controls, you can have admin controls, e.g. training, job rotation, this and that. 20% training, job rotation, warning signs. Okay, so it depends on how many you have. But this is when you have including inspections and observation. If you have training, admin controls plus inspection. But here you have only admin controls without inspection and observations. All right. So training plus inspection to verify that controls are being practiced plus at least one order. Okay. If there is a warning light, operators need to be trained to be aware of what it means. This is just basically training, okay, or job rotation. So you can see this is how you assess the various what do you call it? Prevention effectiveness of various controls and determine the effectiveness of those various controls. Now, here you have a risk scoring, okay, based on the risk matrix I told you about. Usually the two-dimensional risk assessment matrices, basically using likelihood of the events and severity of occurrence. You can see here, you've probably seen this before. So you have the severity of occurrence and you have the likelihood. And this is also a 5x5 matrix, okay. You can see that the highest number is 25 and the lowest number is 1, okay. And this is the categorization. Anything greater than 12, okay, is serious, okay. And anything greater than basically anything greater than 12 has a particular value. Anything greater than 20 or greater than 16, anything greater than 16, okay, it's 16 to 20, 25, okay, 12 to 16, it's probably going to be called very high, and this is going to be high, and then 5 to 11, okay, 5 to 11 is going to be called medium, and then 3 to 4 is probably low, and then 1 to 2 is very low. Okay, based on this categorization of the system, I can see the partitioning. But if you have something something that is very serious in terms of the severity, and you have the likelihood to be seldom, you can simply just come to this matrix and then determine that it is what? It is 9. Or simply multiply 3 by 3 gives you 9. Okay, 3 by 3 gives you 9, okay? And then that falls in what region? Medium, in the medium category. Similarly, you have something that is minor, which is 2, and remote, this gives you 4, okay, which is low, right? So how do you treat this? What are the actions you need to take when they are low, when they're medium, when they're high? And this is something else. So let's look at another example here. You can see these are some standard systems that you can use. By the ANSI, which is usually for machine risk assessment and things like that. ANSI Z10, which is safety management. Z60, which is risk assessment. And this one is the military standard. Z590.3, this is prevention through design. So you can see here, this one has qualitative, okay, qualitative. This one is semi-quantitative, which means it uses some numbers. Qualitative, semi-quantitative uses some numbers. So you have probability of occurrence multiplied by severity, and the matrix is, they use a 4x4 matrix in this. This uses a 5x5 matrix, 5x6 matrix, 6x4 matrix, and 5x5 matrix. I personally prefer to use a 5x5 matrix. Okay, I personally prefer to use 5x5 matrix. And the risk levels and categories, you can see when you have 4 categories, you have high, medium, low, and negligible. High, serious, medium, low. Highest, okay, is number 1. And they have 2, 3, 4, and then lowest, okay. So all these are anything between highest and lowest. We have 5 risk levels. We have high, serious, medium, low, and eliminated, which is lowest or is not negligible or inexistent. We have very high risk, moderate risk, and low risk for 4 descriptive risk levels. Now, in terms of risk scoring, as we might have mentioned previously, that this is basically a formula where you simply multiply the severity by the likelihood, and this gives you the risk score. Okay. Now, risk scoring system with 3 or 4 risk factors are becoming more common. Okay. So these are just 2 factors. Okay. This is a 2-factor risk scoring system, but some experts believe that there are other factors that also influence the characterization of the risk. So in that way, they add a 3rd or a 4th factor, such as failure detectability, especially when you're talking about a system or an equipment, or control effectiveness, as I showed you previously, in terms of determining or factoring into the effects of or the effectiveness of existing controls. Also, issues of vulnerability, especially when you talk about environmental risk assessment or public safety, the vulnerability of the community might be considered, and there might be other factors as well. Okay, so usually when you do that, you have more than 2 factors, that is 3 or more. We call it a risk priority number. In that case, we may say severity. They also do this in what you call RBI, which is risk-based inspection for facilities, or risk-based inspection and maintenance for equipment and things like that. So you may have what you call a priority number, where you multiply the severity by the likelihood, as well as the detection. Okay, all right, the rate of detection of the rate of damage of the equipment. Okay, this might also influence the risk, and then you may include this and come up with another number called the risk priority number. And some people think that you shouldn't just keep multiplying all the factors. You may also have divisions. For example, you may say severity multiplied by the likelihood divided by the detection. So anyway, people come up with various formulas that they consider to better define the risk. So here it says to more accurately score risk levels. Manuel is one of the authors on the safety management. He said he proposes that the severity receive 50% weighing to reflect the impact severity has on incident outcomes. In the following equation, the rating for occurrence probability and rating for frequency of exposure are added together and then multiplied with severity. So Manuel is proposing a different formula here, that for severity should take 50%, okay, of the entire risk, while probability and frequency should take the other 50%, okay. So in that case, here is proposing that probability should be added to the frequency of exposure. All right, and here's using probability of occurrence should be added to frequency of exposure, and then after that you multiply this with the severity and then determine the risk. Okay, so this is another way also to look at the risk score, or to determine characterize the risk. So all this may depend on various experts, various professionals, also the system or the scenario in question. And you might, one way of calculating the risk might be more closer or might be more effective than the others. So all this, you may decide all this in establishing the context of your risk assessment, in defining the scope, objective, the nature of your risk assessment. You may want to define or determine which ways to calculate the risk is better. But for a start, you might want to use something that is common in your problem domain. Okay, something that's common in your industry, it has been used successfully by other successful companies or organizations. You want to start with that, and then you can gradually grow from that into something that you consider to be more robust and something that you consider to be more effective. So that brings us to the end of this session. Thank you guys for coming. And then at this point, I will receive any of your questions.